So we're going to find 5 key elements to what it would take to graph a rational function. And these are the 5 we're looking for over here on the right-hand side, and we'll fill them in as we go. Now, they're not going to be found in order because we're going to follow my 6-step process over here on the left-hand side, starting, of course, with step 0, which is just the way to do step 1. So we're going to begin by identifying points of discontinuities, and to do that, we set the denominator equal to 0 and solve. It's already factored, so step 0 was accomplished before we even turn the problem open here. So we go ahead and get 2x equals -3 and x equals -3 halves as our point of discontinuity. So this is an undefined value. If my question on the right had asked me, what's the domain? The domain would be all real numbers, comma, x can't be -3 halves. But that wasn't the question. The question that is actually more important is what type of point of discontinuity is it? Is it a vertical asymptote or is it a hole? There's only one, so one of them will happen and one of them won't. So my job will be to continue down the steps in order to find the right thing. Well, factoring the numerator, step 2, has already been accomplished for me because there's no factoring of the numerator. This problem, 5 over 2x plus 3, is in simplified form already. So what that means is that this -3 halves will not be reducing out. And so immediately I can say that my vertical asymptote is that value, -3 halves. That means there is no other point of discontinuity to produce a hole. So I go ahead and cross out and say there are no holes. So all of this is just an ongoing list assort activity. So we reduced, we found that we have none of these, and we are looking at a vertical asymptote, checking that off. Now what we do is set the remaining numerator equal to 0. Well, that's kind of awkward here because now we're saying 5 equals 0. That's my numerator. Well, 5 can't be 0. So if 5 can't be 0, then we have no X-intercepts. So we come over here to our X-intercepts and we get rid of that line. There aren't any. So we keep working the process, and now we evaluate f of 0 to do our Y-intercept. F of 0, we're looking for the reduced version. So f of 0 means I just plug in 0 to my function up top, 5 over 2 times 0 plus 3, which is going to give me 5/3. But that's needing to be written as a coordinate, and my box over here is already set up for me, 0, comma, and I just put 5/3 right there, is the Y-intercept. So there's only one subsequent thing to be concerned about, and that's where our end behavior goes, and that's our horizontal asymptote. And a horizontal asymptote is a very simple 3-option process that we've found before. We have to just be concerned about degree of the top as it relates to the bottom. And we have predetermined in previous lessons that if the degree of the top is smaller than the degree of the bottom, then, so I'll put off the side here, the less than, top and bottom, then we get y equals 0 as a result. If it is equivalent in the degree, so if we have equal, then we have the a value of the top divided by the a value of the bottom. And finally, if it is the degree of the top is bigger than the bottom, then we have no horizontal asymptote. So those are the only 3 options with rational functions as previously discussed. So our job is to just compare. Well, we look at the degree of the top, and this is an x to the 0. There is no x up top, so the degree of the top is 0. The bottom degree is linear, it's 1, so the degree of the top is indeed smaller than the degree of the bottom, so this is the simplest case where we just go ahead and take this y equals 0, and that is my horizontal asymptote, y equals 0. And now we've found all 5 details, or lack thereof, of 2 of them for this rational function, and we could begin to graph if that was our prerogative.